Hello, hello, happy Friday. Monday back at school, yay. Hip, hip, hooray. Go Knights! Woo! Speaking of go Knight, my son tonight skated for the first time, like really skated. I was so proud of him. I went 10,000% better than the last time we went. It just clicked. It's like riding a bike and skating for the first time. Something parents will always remember. I pray that you have wonderful memories of your kids and grandkids, and God bless your family and friends. Okay, I think we're going to start with the story today as opposed to midway through since it's a short class. And let me talk about relationships is the category. Ay, ay, ay. So you already heard the girl in the Bermuda beach that we played beach volleyball with, and first thing I said to her was, "So did you have a hot Thanksgiving?" My gosh. And there's a couple other ones, and these I don't know why they're under relationships because this is like not even close to even start of a relationship. So once upon a time, I was in Okotoks and I went to the gym. There was a gym, I can't remember what it's called. It was by the bowling alley and movie theater in Okotoks. And all the weights were at the bottom, and you went up the stairs to use the treadmills and the cardio. And I was using the treadmill, and you could see everyone. You're kind of, I guess, watching everyone work out. And this girl walked in, and she was good looking. And then she was coming up the stairs. Like, whoa, I better turn up the speed. So I went about 35 speed on treadmill. I don't know if they go that fast. But I was running on the treadmill, no problem. And not sure she was behind me somewhere, and no problem. So it wasn't right away, but after about 5 minutes, have you ever been on a treadmill? I don't know. I was running, and all of a sudden, I stepped on the part that wasn't moving. And boom! Face, or I guess hands hit the treadmill. I flew off. It was actually it was probably not as noticeable as it could have been. Like I flew off and got back on, ran back on the treadmill like nothing happened. Oh, but the worst part, that was a pretty bad part, but the worst part was my roommate, Joe, was working on one of the cardio machines beside me. And yeah, that was a story that was not very positive to JO. The other time, and I guess there is some history here, my buddy and I, Miles and I, were driving our bikes together, and we were in high school driving back to my house. I think we just played tennis. And there's a girl on the sidewalk, and she was good looking. And this is classic. We both drove our bikes into each other and crashed. And it was probably made her whole day, maybe in her entire life. And we just laughed and rode away as quick as we could. So yeah, there's my non-existent relationships. Solving systems with fractions. That brings us to that, of course. So we've already done LCDs and LCMs and getting rid of fractions, especially with general form. So in general form, you can't have fractions, so we got rid of fractions. That's what we're doing here. When we see fractions on systems, we get rid of them just like general form. So we multiply each term by the LCD. So to start, we're going to go to page something. Page 9 is where this is at, just almost at the top of page 9. And we want the LCD, which is the LCM, but we're just looking at the denominators. So remember, it's the lowest common denominator. You start with the big number, and is 6 a multiple of 369? Yes, it is. So that's the LCD. Now, what want to show you here, maybe it's best we write it way down here. So LCD is 6. Oops. So what we're going to do is we're going to multiply everything by 6. And when you multiply 6 over 6, it cancels. And when you multiply 6 times 1/3, the 6 divided by 3 becomes 2. Okay, so you can write that down, and you don't have to understand it now. You'll get better and better. But we've done this already. This is what we've already done for general form, so I guess it should be a lot clearer than it was when we started in general form. Here the LCD is not 9, so go to 18. Yes, it is 18, which means we're going to multiply both things by 18, and 18 divided by 6, sorry, both terms by 18. 18 divided by 6 is 3. And if it's truly an LCD, then it's always going to divide by the denominator, so 18 divided by 9 is 2. So here it'd be 2x, and here it'd be 3y. You'll see what I mean when we have some equations. 20, start with 20. Is 20 a multiple of 5? Yes, it is. So the LCD is 20. So here you would multiply this term by 20, and the 20s would cancel. And you would multiply the y term by 20, and 20 divided by 5 equals 4. So you can see all the denominators cancel. That's the whole point of this, is to get rid of fractions. What's the, oops, I just did one for you. Good job. Okay, do D on your own. Find the LCD and then try to cancel like I've been showing you. LCD of 12 and 8. Dun dun dun. Not only was it painful for my ego. Is 12 multiple of 8? No. Go to the next multiple of 12. 24. Yep, 24 is the LCD. So to do this question, you would divide 24 divided by 8 to get 3. And then 24 divided by 12 to get 2. And usually there'd be like a number here, so you'd have to multiply that by 24 as well. But again, we're just kind of setting the table for number 9. And I want you to write number 9. We'll do B and C first, so you can write down B and C, or write down B, and then we'll do A. You do A on your own. Okay, but we don't have enough room to do B or any ones of 9, so let's write it on a separate piece of paper, please. This is on page 9 in the handout. So 9B, muchacho divided by 2, subtract nacho cheese, subtract 4, all divided by 2. Sorry, divided by 4. Equals 2z. And the other equation is 3 muchacho fourths, subtract nacho cheese fifths, equals 5er, also known as a fin. Okay, so first step is to get rid of fractions. That's the whole point of multiplying by the LCD, and I'm surprised I haven't written that down. I apologize. So write down get rid somewhere on page 9, margins, or just above where it says together 9B, C. Write down get rid of fractions by multiplying by LCD. I don't think I wrote that down because we've already done it for general form, but I should have. Sorry, multiplying each term by the LCD. Okay, so if there's a number all by itself, you still have to multiply it by the LCD. Lowest common denominator. Okay, I'm going to get you to write that down, and I'm going to erase exactly what I wrote down so I can start doing some math with this equation. Use the system of equations. Okay, get rid of fractions by multiplying each term by the LCD. Okay, so we are looking at the denominators. And we start with the big one. 4 is 4 a multiple of 2, 4, 6, 8? Yes, it is. So we multiply by the LCD, which is 4. So you're going to multiply. This is going to be the hardest part, and the place where I see the most mistakes is students don't multiply the number by 4. You have to multiply each term by 4, otherwise the equation, the equal sign, does not stay balanced. Then you have to multiply this by 4 and this by 4. So 4 divided by 2 is 2. If it's an LCD, it's always going to multiply by the denominator. 4 divided by 4 cancels. Why? Because 4 fourths is equal to 1, and 1 times anything is the same thing. So that when I say cancel, that doesn't mean it equals 0, it equals 1, and 1 times anything is anything. That's why it disappears. And then 4 times 2 is going to equal 8. So here, I've got 2 muchacho left over. I multiply the number with whatever letter I see and don't cancel. Now this is the tricky part. When I have a subtraction sign here, I have to bring it down, but notice I put these blue brackets in. It subtracts this whole term, so I need to put brackets and write yourself a study note and a study star that you have to put brackets. Otherwise, you're just going to put subtract nacho cheese, and you're not going to subtract the -4, and you're going to have a sign mistake that's going to blow it up. So if you get a weird answer, your answers don't divide nicely, and you get, I don't know, 57/13 or something silly like that, you have to look to see if you missed a sign here. And then 2 times 4 equals Frosty. And now we're going to get it in the form m and n term and then equals a number. So here is my blue guy. Yeah, I'll stick with blue. So I'm going to distribute next, collect like, or no, there's no collecting like terms, and then just move the number to the other side. So subtract n plus 4, that's important, and then I want my numbers on the right side. It's just easier to deal with. So I get 2 muchachos subtract nacho cheese equals kitty cat. And before I do this one, I want you to just look at it, digest it, make a game plan, and see if you can visualize what's going to happen on this one. Knowing that we have to multiply by the LCD to get rid of fractions. LCD equals not 5, not 10, not 15, but 20 is a multiple of 4. So multiply by 20. Multiply this by 20. And you have to multiply the 5 by 20. 20 divided by 4 equals 5. So that's 5 times 3m. 20 divided by 5 equals 4. Now you write down everything that's not canceled, and if there's 2 numbers together, you multiply them. So 5 times 3 is 15, muchacho. Now you just write down everything that you didn't cancel. This is a negative, there's a 4, there's an n. I'm kind of craving nachos, we'll probably have one. And then 5 times 20 is 100. And now you go for elimination using this equation and this equation. Okay, so when you get a question, I'm not going to have a lot of these because you can see they're fairly long, but I need to, it's in the curriculum, so I need to test you on at least a couple of questions on how to get rid of fractions. So now it becomes an elimination question, okay, because it says solve by elimination. If it didn't say solve by elimination, just said solve, you could use substitution or graphing calculator if you wanted to, but I would still choose elimination. So I'm going to put these together, these system equations. Same system, just no fractions. And now that makes me want to find the m's of 30 and -30, but that's changing both. So I'm going to, I have a -4, I need to multiply and make this into a +4. So what am I going to multiply the top by so that -n becomes +4n? And if I just multiply by 4, I'm going to get -4. I already have a -4. I need a +4. So I have to multiply everything by -4. It's a little confusing because it's a double sign. Now I multiply everything by -4. I get -8 muchacho plus 4 nacho cheese equals -16. Don't forget that one. And then I can rewrite my bottom equation as is. And we kind of cross our toes on this one, and hopefully it works out and divides evenly. And sometimes we get like 23m or something. In this case we don't. We get 7m. And we get 84, which I'm happy about because I know my 12 times tables. Okay, that's all right. M equals 4. And now you know the next step is to, there we go, show that too. And now we sub m equals 12 into either equation. And I'm going to let you use these equations, even though these might be wrong because you manipulated them. You don't need to use the original equations when they're fractions, okay? So I'm going to let you use whichever purple equation you want. I would assume that you agree that the top one is easier because it's smaller numbers. And if m equals 12, you put 12 there. And I've had a couple questions on why do you do this two different ways? You do it one way and then the other way, and yes I do, because there's two ways you can do it, and then it doesn't really matter which way you do it at this point. So I'm going to do both for you again, which I did several times already, but if you don't remember, there's two ways to do this. To get n by itself, you can subtract 24 on both sides, and don't forget to bring down that negative, and then divide by -1, or multiply by -1. And you get 1220 as your answer. Or, from this way, you can bring the n to the other side and bring the number to the with the other side. So if you add n and subtract 4, these cancel, and you're left with n equals 24. You get the same answer. It's up to you. Whichever you want to do, stick with the negative n and divide by -1. It's safer to do it this way if you understand it, though. You don't. I've seen some wrong answers where students just are moving things to the other side of the equation. They're not changing the sign. We have to do the opposite operation to get something to the other side, the opposite sign. Okay, this one's safer because you don't have to divide by negative. And you can see it's actually less work too. I don't care, I will mark them both right and give you full marks. So 1220 seems to be our answer. Now, when you check this, I want you to check in the original. The only way we can be sure is if original equations. So 1220, does it work with these guys? Does 1220, oops. Does 12 and 20 work here? Does 12 and 20 work here? So in this case, you'd have 12 divided by 2, which is 6. Subtract 16 divided by 4, which is 4. Does that equal 2? We're pretty happy with that. And this is 36 divided by 4, which is 9. Subtract 20 divided by 5. Does that, yeah. So you can see even this long question, when you check it quickly, you're just so happy. You know all your hard work has paid off and you didn't make a sign mistake. Good for us. Yeehaw. 9B in a nutshell. Go ahead and pause if you need to keep writing anything down. And I'm going to pause this now. Pause, 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 pause. And when you're ready, we'll go to 9C. Okie dokie, 9C. Now, you could do this for 9C. Go ahead and write it down on a separate piece of paper. You could distribute this. I'm not going to. and you would get 2 over 2x, which is just x. Subtract 1/2 y, which is the same thing as y over 2. That means the same thing, 1/2 y and y over 2. There's a imaginary 1 here, so that's where the 1/2 y comes from. However, I'm going to just multiply the fraction by the LCD, and it's going to be a lot easier, and you certainly can do that, and we've done it before. So this, if you distribute it like this, it's an unnecessary step. If you do it correctly, you'll get the right answer, and I'll give you full marks. But there's no real reason to. So when you find the LCD of the first line in your equation, you look at the denoms. So 4 is for an LCD. Yes, it is. So you multiply this by 4. Multiply this by 4. It could be the top, front. In this case, it's a little easier to cross it out here. And don't forget to multiply the 6 by 4, which is the most common mistake. 4 divided by 2 equals 2, and 2 times 1 is 2. So I'm just going to, because I see a lot is 2 times 2x, and they make it 4x, and then subtract y. But no, this 2 is actually distributing to both brackets. I don't want you to do that 2 steps in one, because I've seen students do that, and they make silly mistakes when they do 2 steps at one. So I would encourage you to stay patient, take an extra 10 seconds, just write down that as 2, and write down the bracket 2x subtract y, and then what's not crossed out here, plus 3x, and that equals 6 times 4. Don't forget to multiply the 6 by the LCD as well. Then you can multiply or distribute and get 4x subtract 2y plus 3x equals 24. And then you collect the likey termies and get 7x subtract 2y equals 24. And we've rewritten that purple mess into this beautiful blue. Did hurt. Okay, look at, and actually I'll even let you start, because this is the whole purpose of this Friday, is to get rid of fractions. So see if you can find the LCD of the second linear equation and multiply each term by the LCD and get rid of fractions. That's the whole point. I'll just give you a minute to do that first step. Twenty-three sounds like a fine place to start. Coach Sean Monahan and Flames starting next Thursday. The LCD is not 3, is it 6? Yeah, 6. So you multiply everything by 6. Multiply by 6, and don't forget to multiply this by 6 in the front too if you want. And when you divide, so the next step is you immediately divide the LCD by the denominator. That gets rid of the fraction. So 6 divided by 2 is 3. 6 divided by 3 is 2. And 6 divided by 3 is 2. So now you multiply all the numbers and anything that's not crossed out. So this is 3 times 1 is 3. Keep the x. Subtract. 2 times 1 is 2. Keep the y. And then 2 times 2 is 4. And what do you got? Okay, so go ahead and finish that one with elimination. And get a ordered pair and check it. And then do 9a. We didn't do 9a. And when you're done all of that, you can unpause. So go ahead and pause, finish this one off, and do 9a by multiplying by the LCD to get rid of fractions. And then just do an elimination question. Remember, elimination means the same numbers, different signs. Pause, 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 pause. Okay, so these are the two equations. We have to eliminate one of the variables. And I've always told you to change the signs. Now, you don't have to, but this is a subtraction is something I don't like teaching. It works out very good for this one because 7x subtract 3x is 4x, 24, nice. But the problem is half the time they have negative signs here. So if you subtract these and you get 0, I've seen way too many times, in fact more times than not, students will put a 4 here and then you subtract these and you get 20. And that's wrong because you're actually subtracting a -3. And when you subtract a negative, that means plus 3. And this actually should be not 4x, but 10x. It's a double sign that's hard to see, and it's really, you don't need to even deal with it. If you do it that way, you go and do it correctly, I'll give you marks, of course. And I know some people might be looking at this podcast and saying, well, why wouldn't you just subtract them? And you could, but that's why I don't subtract, is because it just gets too many unnecessary lost marks, and it's a hard double sign to see. So you could subtract, but I'm not going to. I'm going to multiply one of, oops, that's not usually how I write it. I'm going to multiply one of the equations, and I usually pick the top equation to multiply by -1, so that I have a 2y and a -2y, and I can just add them and cancel. Okay, so I have a -7x plus 2y equals -24, and the bottom one stays the same, and you can see that this cancels. We're left with x equals -20. Say what? Let me just check that again. Da 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 da. Scooby dooby dooby. What? Oh, that's a 7. Okay, it's a 7. Wow, glad I checked that again. So it's not x, it's a -4x. And thank you for catching that. Dividing by -4 gives you x equals 5. That means a little more comfortable. And then I sub x equals 5 into one of the equations. The bottom one is easier. So sub x equals 5, and 3x subtract 2y equals 4. 3 times x becomes 3 times 5. And we get, we're going to get a fraction. 15 subtract 2y equals 4. Let's move that over there and that over there by adding 2y to both sides and subtracting 4 on both sides. And we get 11 halves, which is 5 1/2. Divide by 2. So 11 halves, which is 5 1/2 equals y. I am nervous about this one. So I'm going to check over here first, see if I did anything. Let me see if I made a sign mistake. Plus 2y subtract 24, add -4, -20, 5. I sub that into 5, I get 15, and that's a 4 there. Okay, so now I check it. If I don't find anything wrong, I check 5 and 5 1/2, which is odd. 5 and 5 1/2. Okay, so I'm looking at the purple here, and bear with me. So I got 4 1/2, half 4 1/2, 2.25. No, that's not going to work. Hold on, 20, 15 fourths. Sorry, I wasn't looking at the fraction. I was looking at the blue. So 15 fourths. Is that what it is? Yep. Which is 3.75. Well, I got this. That is correct. And you can just punch this in your calculator. Here I got 5 halves. 5 halves is the same thing as 2.5. So I'm going to use 2.5. Subtract, is it a third? Yep. Subtract 1/3 of 5.5. Ay, ay, ay. Equals 2/3. So 11 fourths and 5 halves make 5 halves 10 fourths. Subtract 11 fourths does not equal 2/3. Pause, I'm stuck. Check. Okay, that took me, I think, 10 seconds to figure out. It's going to take way longer than that. Right here, this, I even said 1/3, but I wrote down 1/2. So this should be a third. Right there. Ugh. That should be 1/3. So when I do that, I get 5 halves. That's what 2.5 means. Subtract 11/6. And if I do 5 halves, I'm going to actually just work on the black line. 5 halves and 11/6. I need to make them both into sixths. So I'm going to multiply by 3 thirds to get 15 sixths. Subtract 11/6, and now I subtract the numerator and keep the denominator. Does 4/6 equal 2/3? This was a very fun question for me. Yay, it's been a long time since I've had a few fractions and things that worked out that they didn't look like they were going to work out. So that's the answer. Good job. If you got that, brilliant. If not, no big deal. If you doubted it, I can certainly see why. But if you can't find a mistake, you just go and check to see if your answer works. And then you become a fraction master. All right, as promised. So I'll let you pause right here if you need to. Not sure exactly. You should have had that part written by now. But I'll let you pause here. Otherwise, I'm going to extend and go on to 9a, which is certainly an easier question. And hopefully you remembered when we did general form, if you only have one fraction, that's the LCD, and the denominator is the LCD. I'm going to, I usually don't write the original question when it's like this. I just rewrite it with the variable and the term and combined. So you have to know, and star this one, you have to know that these are equal. Okay, these mean the exact same thing. 1/2 y means the exact same thing as y over 2. They're both 1/2 y. You can write it in two different ways. So that's why I did, to help me out a little bit. And then this one, knowing this, can you please rewrite the second equation like I did over here? And this is simply x over 3 plus y over 4. This is easier to deal with, so I'm going to rewrite them. And this is how you would punch them in your calculator. You don't need to punch in the 1. You just need to put x over 3 for 1/3 x. Remember, there's an imaginary 1 there. Okay, I need an LCD. This, again, if there's only one denominator, you multiply by 2. black and purple. That's northwestern colors, I guess. So this is 6x. The 2's cancel. Whenever it doesn't cancel, you write down. And two things you have to multiply that don't. Two terms you have to multiply that don't have denominators. You have to multiply every term. What's the LCD of 4 and 3? 4, 8, 12. Oh, ding, 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 ding. You multiply everything by 12, including the 3. What's 12 divided by 3? 4. What's 12 divided by 4? 3. So write down everything that didn't cancel. 4x plus 3y equals 36. And now I'm going to do elimination. I'm going to do the multiply. I guess you could do the first equation. I'm going to just bring that down here and make that the second equation now. And I don't think I can. I'm confusing too many people here. So multiply that equation by 3. Oh, I ran out of room anyway. Doggone it. Ay, ay, ay. That's one of my dad's quotes. Ay, ay, ay. Okay, so I guess I'll stick with the top equation being the top equation and the second equation being the second equation, since that didn't save me any time. And now I'm going to multiply this equation by 3 so I can have a negative 3y and a positive 3y. If you did something harder and made 12x and negative 12x, you're doing extra work, but if you get it right, you get it right. But try to look at the x's and the y's and see which one is easier. Go ahead and distribute that. Leave the bottom equation as is. And now I'm happy because I got 22x equals 66. When I add, same sign, same number, different sign, divide by 2, 2, and you get 3. And you sub x equals 3 in either equation. Even these have bigger numbers. I don't have a negative sign, so I'm going to choose my bigger numbers. Doesn't matter, you'll get the exact same answer. So wherever I see 4 times x, I put 4 times 3. And I'm going to skip a step. I know 4 times 3 is 12, so now I have to subtract 12 on both sides. So 12 subtract 12 is 0. You get 3y equals 24. And I'm getting lazy. Divide both sides by 3. And you get Frosty. Therefore, 3, 8 is the solution. Let me check it, and let me make the 8 a proper 8. 3, 8. And if I work with the original equations, 3, 8, x equals 3, y equals 8, x equals 3, I like that one. I get 9 subtract 4 equals 5, and I get 1 plus 2 equals 1, 2, 3, 3. Ta-da! Right on. So you have homework, and it's just number 11 and 12 on page 10. Okay? So homework, page 10, number 11 and 12 have fractions in the questions. The first step is to get rid of the fractions by the LCD. Hope you have time to work on a couple of those. And you have an amazing, awesome weekend. God bless. Have an awesome day. Ha ha ha. J.O. out.